Welcome to science, to sleep by. Tonight, we drift beyond our world, beyond the blue skies, beyond the pull of gravity into the soft, glowing arms of our home galaxy, the Milky Way. As you settle in, close your eyes, breathe deeply, and let your thoughts stretch far, far away. We'll travel together through space and time, not to make you feel small, but to remind you of how beautifully connected you are to everything that ever was. This is Science to Sleep By, and tonight's journey asks one quiet question. How small are we inside the Milky Way? Imagine lying beneath a clear night sky, somewhere far from the glow of city lights. Above you stretches a ribbon of faint light, a silvery mist that seems to divide the heavens in two. That mist, that delicate band, is not a cloud. It's the Milky Way itself, our galaxy, our island in the great cosmic ocean. For millennia, humans looked up at that luminous arc and gave it names filled with poetry and wonder. The Greeks called it Galaxias Kyklos, the Milky Circle. The ancient Chinese saw it as the Silver River. In countless cultures, it was seen as a bridge between the realms of gods and mortals, the path of souls, or the river of stars. But beyond myth and imagination, the Milky Way is real, vast, magnificent, and almost beyond comprehension. The Milky Way galaxy is a sprawling spiral system, a flattened disk of stars, gas, and dust, spanning around 100,000 light-years across. To grasp what that truly means, imagine traveling at the fastest speed possible, the speed of light, about 186,000 miles per second. Even at that unimaginable velocity, it would take you 100,000 years to cross our galaxy from one end to the other. And remember, that's not years as we know them, that's 100,000 full orbits of Earth around the Sun. Each second would carry you 186,000 miles farther, yet the journey would still take longer than the entire history of human civilization. Within that immense space, astronomers estimate there are between 200 billion and 400 billion stars. Each of those stars could host its own family of planets, systems like our own solar system. Perhaps some with worlds like Earth. Perhaps some utterly alien. Even if only a fraction of those stars have planets, the number of worlds scattered across our galaxy is staggering. Imagine trying to count them one by one at a rate of one planet per second. Even after millions of years, you wouldn't be close to done. The Milky Way's structure is as elegant as it is immense. At its heart lies a dense bulge, a spherical region packed with ancient stars, and, at its very center, a supermassive black hole known as Sagittarius A. This black hole has a mass more than 4 million times that of our Sun. Around this heart, the galaxy's disk spirals outward in graceful arms-long, curved tendrils filled with stars, nebulae, and interstellar dust. These arms are where most of the galaxy's newborn stars are found, glowing hot and blue against the darker background of space. Between the arms lie the quieter regions, where stars like our Sun circle calmly through the galactic night. If we could step back and view the Milky Way from the outside, it would appear like a great, glowing pinwheel turning slowly in the void. The central bulge would gleam like a golden core, while the spiral arms would shimmer with bluish-white light, peppered with the faint pink glow of star-forming clouds. Beyond the bright disk lies a vast halo, a nearly invisible sphere that extends far beyond what the eye could see, filled with ancient, dim stars and mysterious dark matter that makes up most of the galaxy's mass. To imagine the Milky Way's scale in human terms is almost impossible. If the entire solar system from the Sun to Pluto were reduced to the size of a quarter, then the Milky Way would stretch as wide as the continental United States. Even the Sun itself, enormous though it is, would be just a speck of dust compared to the galactic scale. Every planet, moon, comet, and asteroid you've ever heard of, all of them orbiting within that tiny dot, while billions of other stars and systems fill the surrounding space. And yet, even the Milky Way, for all its grandeur, is only a modest galaxy among billions. It's not the largest, nor the smallest, a medium-sized spiral adrift in a vast cosmic web. But to us, it is everything. It is home. Every star we can see with the naked eye belongs to the Milky Way. Every nebula, every cluster, every glimmer of light that decorates the night. They are all parts of our galactic family. When we gaze up at the sky, we are not looking outward from the galaxy. We are looking through it, peering across its luminous disk from our position inside one of its arms. The numbers are so vast that they defy ordinary comprehension. Light years, millions, billions. These are not figures we can truly feel. But we can try to imagine the distances in another way. Suppose you could shrink the Milky Way down to the size of a dinner plate. On that plate, our entire solar system would be smaller than a single speck of dust. The distance between our sun and the next nearest star, Proxima Centauri, would be less than the width of a human hair. And yet, on that same plate, there would be hundreds of billions of other tiny specks, other suns, other systems, other possible homes. The Milky Way doesn't just stretch in size. It stretches in time. Our galaxy is around 13 billion years old, nearly as old as the universe itself. Long before the Earth formed, long before the sun ignited, stars were already living and dying within the Milky Way's early arms. Their death scattered heavy elements carbon, oxygen, iron into space, where they eventually became part of new generations of stars and planets. The very atoms that make up our bodies, the ones that let you breathe, think, and dream, were once forged in the hearts of those ancient stars. In a very real sense, we are the galaxy, made conscious of itself. Our place in this immense structure is small, almost imperceptible. We live near the inner edge of a minor spiral arm, called the Orion Arm, a modest branch between the larger Sagittarius and Perseus arms. From here, we look inward toward the glowing center of the galaxy, our view obscured by vast clouds of dust that stretch across the sky like dark rivers. We look outward and see the outer spiral, fading into the blackness. Everything we know, every history, every memory happens in this small, quiet neighborhood, drifting through a galaxy so vast it could swallow 100,000 worlds like ours and never notice. Astronomers study the Milky Way not by seeing it from afar, but by looking along its edge, mapping the faint traces of light and radio waves that reveal its structure. Like someone trapped inside a forest, we can't see the whole shape, but we can measure and imagine it, piece by piece, until its grandeur takes form in our minds. And when we do, when we realize what it means to live inside such a colossal, shimmering wheel of stars, we begin to understand just how immense, how breathtakingly vast our cosmic home truly is within the vast, spiraling arms of the Milky Way. There lies a small, quiet corner where our story unfolds. It is here, about 27,000 light years from the galactic center, that our sun makes its home. The sun is not a remarkable star by galactic standards. It is an average G-type main sequence star, warm and steady, neither the largest nor the smallest, neither the brightest nor the dimmest. And yet, to us, it is everything. Around this unassuming yellow star orbits a collection of world's rocky planets, gas giants, icy comets, and scattered dust, all held in the gentle grip of the sun's gravity. Together, they form our solar system, a tiny archipelago of light adrift in a sea of stars. If we could rise above our solar system and look down upon it from afar, we would see a fragile arrangement of circles and ellipses, each planet tracing its path with patient precision. Closest to the sun, Mercury races along in just 88 days, its surface scorched and airless. Then comes Venus, shrouded in thick clouds of sulfuric acid, glowing like a brilliant pearl in the night sky. Next is Earth, our blue and white oasis, wrapped in a thin veil of atmosphere and alive with motion. Beyond Earth lies Mars, the red wanderer, cold and quiet, a world that once might have flowed with rivers. Farther still are the gas giants Jupiter with its swirling storms and Saturn adorned with its rings of ice. Then come the distant ice giants, Uranus and Neptune, tilted and windswept, circling slowly at the edge of sunlight's reach. Beyond them, in the frozen dark, drift the remnants of creation comets, dwarf planets like Pluto, and countless icy fragments that whisper the ancient story of the solar system's birth. This fragile collection of orbits, stretching only a few billion miles from one end to the other, occupies a space so minuscule compared to the galaxy that it might as well be invisible. The entire solar system, if placed within the Milky Way, would be smaller than a speck of dust on a vast beach of stars. And yet, within that speck lies everything humanity has ever known. Every civilization, every dream, every song, every heartbeat has taken place within this tiny bubble of light around a single, ordinary star. Our solar system drifts along one of the Milky Way's spiral arms, known as the Orion Arm, or sometimes the Orion Spur. This arm is a smaller, less prominent branch situated between two of the galaxy's major arms, the Sagittarius Arm on one side and the Perseus Arm on the other. It's not the grand, star-packed avenue of the galaxy, but more like a quiet suburban street between two bustling city boulevards. And in that quiet street, we orbit, moving through the galaxy's disk in a slow, steady path. It is easy to forget that we are not stationary. Our solar system is hurtling around the galactic center at nearly 500,000 miles per hour. And yet, from our perspective, all is calm, all is still. The sun rises and sets, the planets turn in their silent orbits, and life continues in its small, beautiful rhythm. The sun itself is a middle-aged star, about 4.6 billion years old, having already lived about half its life. It burns with a steady fusion of hydrogen into helium, releasing the energy that warms our world and lights our sky. Around it, the planets and moons follow paths set in motion long ago, bound together by the invisible force of gravity. This delicate gravitational balance keeps the solar system in harmony, a cosmic dance that has endured for billions of years. Even the smallest changes, a nudge from a passing comet or the faint tug of distant stars, can subtly alter the rhythm, but for now, it remains a stable and serene system. From our vantage point on Earth, the night sky reveals only a tiny fraction of what surrounds us. The stars we see, scattered like diamonds on velvet, are neighbors in our local galactic neighborhood, lying within a few thousand light-years of the sun, of the galaxy, its outer arms. Its distant clusters, its dense central bulge remains forever out of sight, hidden by distance and the interstellar clouds of dust that veil the galactic plane. Yet even within our limited view, we can sense the immensity of what lies beyond. Every point of light we see is another star, another system, another possible home for life. Our solar system, though small, occupies a remarkably stable and safe region of the galaxy. Astronomers call it the galactic habitable zone, an area not too close to the volatile galactic center, where radiation and gravitational chaos would make life nearly impossible, and not too far into the sparse outer reaches, where the heavy elements needed for planets and life are scarce. Here, in this quiet orbit between spiral arms, the sun and its planets travel through relative calm, no nearby supernova to threaten life, no dense star clusters to disturb planetary orbits. It is, in many ways, the perfect neighborhood for life to take root. And that life, on one small, blue planet, has learned to look outward. From the first humans who stared up at the Milky Way in awe, to the astronomers who mapped the stars, to the spacecraft now leaving our solar system entirely, we have always been seekers of perspective. The Voyager probes, now billions of miles from Earth, carry with them a faint human voice, a record of who we are, cast into the darkness. They have passed beyond the reach of the sun's wind, into the interstellar medium that fills the space between stars. From that distance, Earth is no longer visible as a world, not even as a point of light. It is a pale blue dot, as Carl Sagan once said, suspended in a sunbeam. That dot, that shimmer of blue light, contains every story we've ever known. The modesty of our solar system's place within the Milky Way is humbling. The galaxy itself is so vast that even light, moving at unimaginable speed, takes hundreds of centuries to cross it. Our entire history from the dawn of human civilization to this very moment is a flicker in comparison to the time it takes for the sun to complete a single orbit around the galactic center. Every 230 million years, our solar system makes one full revolution, a cosmic year in which continents shift, species rise and fall, and stars are born and die. We, the inhabitants of a small world circling a small star, are passengers on this immense, unending voyage through the galaxy's spiral arms, carried by forces older and grander than we can fully imagine. And yet, despite the overwhelming immensity that surrounds us, our solar system is the one place we can call home. It is the cradle of our existence, the stage on which every moment of our history has unfolded, the small yet radiant corner of the Milky Way where, somehow, life found a way to awaken and begin to wonder. When we gaze up at the night sky, it feels as though the stars are close together, like tiny lanterns scattered just beyond the clouds. Yet that appearance is a gentle illusion, a trick of perception born of vast distances collapsed into a single view. In reality, each of those stars is separated from the next by an almost unimaginable gulf of empty space. The universe is not crowded, but profoundly spacious. Between every point of light lies a stretch of darkness so immense that even the fastest thing known, light itself, takes years, centuries, or millennia to bridge it. The night sky, beautiful as it is a tapestry woven from light that has traveled across time and distance to meet our eyes. To understand how far apart the stars truly are, we can begin with our nearest stellar neighbor. The closest star system to the Sun is Alpha Centauri, a triple star system located about 4.37 light-years away. That means the light we see from it tonight left the star more than 4 years ago. One of its members, Proxima Centauri, is the closest of them all, just a bit over 4 light-years from us. In miles, that's roughly 25 trillion miles. A number so large it defies intuition. If we could travel at the speed of light, we'd still need more than 4 years to reach it. But our fastest spacecraft, such as NASA's Voyager 1, would take over 70,000 years to cover that same distance. The gap between stars is not a simple void, it is a vast cosmic desert, empty of solid ground, where even light takes its time to wander. Between our Sun and the nearest stars lies the interstellar medium, a sparse mixture of gas, dust, and radiation. It is not a true vacuum, but it is so thin that a single cubic centimeter might contain just a few atoms. Within that almost perfect emptiness, the Sun's influence fades. The solar wind, a stream of charged particles that flows outward from the Sun, gradually loses strength until it meets the pressure of the interstellar medium at the boundary known as the heliopause. Beyond that invisible frontier begins the true space between the stars, a region where the light of one star begins to give way to the darkness that belongs to another. It is a place of near silence, vast and timeless, where distances stretch beyond the reach of imagination. If our galaxy contains hundreds of billions of stars, then surely they must be close together somewhere, one might think. But even within the crowded spiral arms of the Milky Way, the average distance between stars is still measured in light years. Imagine shrinking our Sun down to the size of a marble. On that same scale, the nearest star would be another marble placed several thousand miles away. Between them would be nothing but empty space. That emptiness is not a flaw in the design of the universe, it is its defining feature. The cosmos is mostly nothingness, with the rare jewels of light suspended like fireflies across eternity. These distances shape everything about the universe we experience. The light from a star does not reach us instantly. It carries with it the memory of when it left its source. When we look at Sirius, we see it as it was 8.5 years ago. When we look at the bright star Deneb, we see light that began its journey more than 2,600 years ago, when ancient civilizations were just beginning to write their stories on clay tablets. Even the faint glow of the Andromeda galaxy, visible to the naked eye on a dark night, shows us light that began its voyage over 2 million years ago, when the first humans had yet to exist. To look into the night sky is to look into the past, to witness light that has crossed the immense spaces between stars and carried with it the echoes of cosmic history. Astronomers measure these distances in light years, not because it's convenient, but because any smaller unit quickly becomes meaningless. A light year, the distance light travels in 1 year, equals nearly 6 trillion miles. In just 1 second, light can circle the Earth 7 times. Yet even at that speed, It takes centuries to travel across the distance that separates the stars within our local region of the galaxy. The sheer scale of space means that communication, travel, and exploration between stars is not merely difficult, it borders on the impossible with our current understanding of physics. To send a signal to Proxima Centauri and receive a reply would take nearly 9 years, even traveling at light speed. For a spacecraft moving at the speeds we can achieve, it would take longer than the entire span of human civilization to make that same round trip. Despite this emptiness, the space between stars is not entirely barren. Within it drifts the remnants of ancient suns, atoms and molecules scattered by stellar winds and supernova explosions. These particles, though sparse, serve as the raw material for new generations of stars and planets. In the densest regions of the galaxy, clouds of interstellar gas begin to collapse under their own gravity, giving birth to new stars that light up the darkness once again. In this way, even the empty space between stars plays its role in the ongoing cycle of creation. The vastness may seem cold and silent, but it is part of the heartbeat of the galaxy itself. For humans, the concept of interstellar distance challenges everything we know about scale and time. On Earth, distance is a thing we can cross. A continent can be traversed, an ocean can be sailed, even the moon can be reached. But in space, distance is something different. It becomes a barrier that defines the limits of our reach. The gulf between the stars reminds us of both our progress and our fragility. We are creatures of a single star system, bound by the limits of physics, yet able to imagine the infinite. Even our most ambitious visions of interstellar travel, massive generation ships, suspended animation, warp drives, or wormholes remain in the realm of theory. The distances are too great. The energy demands too enormous. The fastest object humans have ever built, the Parker Solar Probe, moves at about 400,000 miles per hour, yet at that speed, it would still take over 17,000 years to reach the nearest star. Space, it seems, has a patience that far exceeds our own. When we consider the distances between stars, we begin to see the night sky differently. Those twinkling points of light are not scattered evenly across a dome, but suspended across a three-dimensional ocean, each shining from its own distant shore. Some are so far away that their light has traveled for millennia through the emptiness, undisturbed, until it reaches the back of your eyes and is transformed into wonder. The sky is not a ceiling, but a window into distance itself, into the quiet immensity of space, where time and distance blend together. In that space, the stars are both neighbors and strangers, each one a solitary beacon surrounded by vast darkness, each separated from the next by more than the human mind can fully grasp. If you could step outside the boundaries of our solar system and drift quietly into the interstellar sea, you would find yourself surrounded by a neighborhood both tranquil and astonishingly vast. It is a neighborhood not of streets or houses, but of stars and clouds, a region where light itself becomes the silent messenger between worlds. Astronomers call this region the local stellar neighborhood, a patch of the Milky Way, where our sun resides among a few thousand nearby stars spread across a distance of about 1,000 light years. Though we often imagine the galaxy as a crowded metropolis of stars, in truth, our corner of it is open and spacious, a cosmic countryside dotted with distant suns twinkling across unimaginable expanses. The stars nearest to us form a delicate cluster of relationships, defined not by proximity as we know it on Earth, but by gravity and motion through space. The sun and its planets drift through this region together, orbiting the center of the Milky Way in a vast procession that includes countless other stars doing the same. Each star follows its own path, moving at its own speed, yet all of them are bound by the same invisible force of gravity that keeps the galaxy spinning in its elegant, spiral form. It's a motion so immense and so slow that it takes the sun about 230 million years to complete one full orbit of the galactic center, a journey sometimes called a cosmic year. In that time, entire species can rise and fall, mountains can form and erode, and civilizations can vanish without the galaxy ever noticing. Within this vast stellar landscape, our closest neighbors form a small but fascinating group. Just over 4 light-years away lies the Alpha Centauri system. 3 stars bound together by gravity. Alpha Centauri A and Alpha Centauri B are both similar to our Sun, orbiting each other in a celestial dance that takes decades to complete, while a third, smaller companion, Proxima Centauri, drifts nearby, faint and red, but closer to us than either of the others. Around Proxima Centauri, astronomers have detected at least 2 planets, one of which orbits within the star's habitable zone, that fragile region where conditions might allow liquid water to exist. It's a quiet reminder that even in the vastness, there may be other worlds where the chemistry of life could unfold. Beyond the Alpha Centauri system, other nearby stars add to the diversity of our local galactic environment. Barnard's star, a dim red dwarf just 6 light-years away, is moving rapidly across the sky, one of the fastest known in terms of apparent motion. Then there's Wolf 359, Lalande 21185, Sirius, and Epsilon Eridani, each one unique, each with its own retinue of planets or disks of dust and debris. Some are young, burning fiercely and surrounded by clouds of gas where new planets are still forming. Others are ancient, long past their prime, their nuclear furnaces dimming as they fade into the cool twilight of cosmic time. Together, they form a family of stars, not close in the human sense, but connected by the shared gravitational currents of the Milky Way. Between these stars lies not emptiness, but a delicate web of material known as the interstellar medium. It consists of gas, dust, and charged particles, so thin that a single cubic meter might hold just a handful of atoms. Yet over vast distances, this sparse matter gathers into clouds and filaments, shaping the birthplaces of stars. Some regions are rich in hydrogen, glowing faintly in the light of young, hot stars. Nearby others are dark and dense, hiding within them the seeds of future suns. One such region, not far from our solar system, is the local interstellar cloud, a small, warm pocket of gas through which the Sun is currently passing. It is part of a larger structure called the local bubble, a cavity about 1,000 light-years wide that may have been carved out by ancient supernova explosions millions of years ago. We live, in a sense, inside the faded echo of those long-gone cosmic blasts. Scattered within this neighborhood are other marvels, star clusters, nebulae, and remnants of stellar death. The Pleiades, or Seven Sisters, form one of the most recognizable star clusters in the night sky, a small family of young, blue stars still surrounded by the dust from which they were born. The Hyades cluster, older and closer to Earth, forms the distinctive V-shape in the constellation Taurus. Then there are nebulae like the Orion Nebula, a glowing nursery of star formation about 1,300 light-years away. Within it, hundreds of new stars are emerging from dense clouds of gas, their light slowly burning away the very material that created them. Each of these regions is a reminder that our galaxy is alive with motion and transformation, that even the dark stretches between stars are places of creation. When astronomers map our galactic neighborhood, they often describe it in terms of local structures. The Sun's position lies within the Orion Arm, sometimes called the Orion Spur, a smaller offshoot between 2 of the Milky Way's main spiral arms. Nearby lies the Perseus Arm, a grand lane of bright, massive stars and nebulae, and on the other side, the Sagittarius Arm, winding closer to the galactic center. Our local arm may seem humble by comparison, but it holds many of the most familiar constellations: Orion, Cygnus, Cassiopeia, and Perseus, all part of the scenery that has guided travelers and storytellers for millennia. From our vantage point inside it, we can look across thousands of light-years of stars and gas, each one part of the delicate pattern that defines our galactic home. The galactic neighborhood is not static. Stars move through it on their own trajectories, and over millions of years, the patterns we see in the night sky will shift. Constellations will distort, familiar shapes will fade, and new ones will form. Some stars will approach us, growing brighter as they near. Others will drift away, their light slowly fading into the background. The Sun itself is moving relative to nearby stars, weaving through the galaxy like a slow traveler following unseen roads. Every so often, another star passes close enough to subtly influence the outermost regions of our solar system, where icy bodies orbit in the Oort cloud, waiting for some disturbance to send them inward as comets. These encounters are rare on human timescales, but inevitable over cosmic ones, gentle reminders that even in the vastness, everything is connected by gravity's reach. To visualize our galactic neighborhood is to imagine a three-dimensional sea of light, with the sun as one small point among countless others. Each star shines with its own hue, some golden, some blue, some red, and each one carries with it the potential for new worlds, new stories, and new beginnings. Between them drift clouds of dust that absorb and scatter starlight, painting the Milky Way with streaks of darkness that trace the structure of its spiral arms. Occasionally, a supernova will blaze into existence, outshining all the stars around it, then fade, leaving behind a nebula that will someday give birth to more stars. The neighborhood is dynamic, restless, and filled with quiet beauty, a vast expanse where time moves slowly and creation never truly ceases. Our solar system, though small and fragile, is part of this grand structure, a single mode of light drifting among billions. When we look at the stars in our local sky, we are peering through the window of this neighborhood, seeing not just distant points of light, but the intricate network of the Milky Way itself. Every photon that reaches us is a traveler from one of these neighbors, a messenger from across space, carrying the story of where it came from and how long it has been on the road. Though we often imagine the heavens as serene and still, the reality is far from motionless. Everything in the cosmos is in motion. The Earth spins on its axis, the moon circles the Earth, the planets orbit the sun, and the sun itself, along with its entire family of planets, drifts through the Milky Way on a vast, curving path. The solar system is not anchored in space, but instead sails through the galactic sea at extraordinary speed, caught in the grand rotation of the galaxy's spiral arms. The sense of stillness we feel beneath the night sky is only an illusion born of distance and time. In truth, we are passengers on a celestial voyage that began long before humanity existed and will continue long after we are gone. Our journey begins with the sun, the gravitational heart of our solar system. Everything that orbits it, planets, asteroids, comets, and dust moves with it through the galaxy. The sun travels around the Milky Way center at a speed of roughly 500,000 miles per hour, or about 220 kilometers per second. At that rate, it takes approximately 230 million years to complete a single orbit of the galactic core, period astronomers call a galactic year. Since the sun formed about 4.6 billion years ago, it has made this grand circuit around the Milky Way more than 20 times. Each journey marks an era of cosmic transformation, continents shifting, species evolve, ice ages rising and fading, all while our solar system continues its steady course through the star-filled dark. This motion is not in a perfect circle, but more like an elegant spiral, influenced by the gravitational pull of other stars, gas clouds, and the mysterious presence of dark matter that makes up much of the galaxy's unseen mass. The sun's path gently rises and falls through the plane of the Milky Way, bobbing up and down every few dozen million years like a ship riding the waves of an invisible ocean. As it moves, it carries with it the entire solar system, Earth, the moon, every planet, every piece of cosmic debris, all bound together in a delicate gravitational choreography. From our vantage point on Earth, we rarely sense this vast motion, but the evidence surrounds us. The stars in the sky slowly shift their positions over tens of thousands of years, tracing the changes in our perspective as we move through the galaxy's immense structure. The galactic center itself, around which we orbit, is a region of intense energy and gravity. At its heart lies a supermassive black hole known as Sagittarius A, containing the mass of more than 4 million suns. Though it is nearly 27,000 light-years away, its gravity exerts a subtle but powerful influence on everything within the Milky Way. The sun's motion, like that of all the other stars in the disk, is the result of this gravitational pull, combined with the collective attraction of billions of other stars. The entire galaxy spins as a vast, interconnected system, each star like a bead on a cosmic string, moving in harmony with the rest. As we travel around the galaxy, our solar system also moves relative to nearby stars. We are not simply going in circles, but drifting through different regions of the Milky Way, encountering new stellar neighborhoods over time. Right now, we are passing through a region known as the local interstellar cloud, a thin patch of gas and dust left over from ancient supernova. Millions of years from now, the Sun will exit this region and move into another, perhaps denser or emptier, part of space. Each transition subtly changes the environment surrounding our solar system, altering the flow of cosmic rays, the density of interstellar particles, and the shape of the protective bubble known as the heliosphere that surrounds us. The journey through the galaxy is not only vast in distance, but also dynamic in nature, constantly reshaping the invisible forces that bathe our solar system. To grasp the scale of this motion, imagine the Sun as a glowing spark moving along a spiral path through the galaxy. Around it, the planets circle like small fireflies, each tracing its own miniature orbit while being carried along on the Sun's grand trajectory. Earth, for instance, travels around the Sun at about 67,000 miles per hour, completing one orbit every year. But while it does this, it is also being swept along through the galaxy by the Sun's motion at 500,000 miles per hour. The combined result is a complex, graceful spiral path. Earth never returns to the same place in space twice. Each year, as the planet completes its orbit around the Sun, the entire system has moved hundreds of millions of miles farther along the galactic road. Even within the solar system, every object is in constant motion. The Moon orbits Earth. Earth orbits the Sun. The Sun orbits the galactic center. Comets travel on long, looping paths that take them from the frozen outskirts of the Oort cloud into the inner solar system and back again, their icy surfaces shedding bright tails of gas as they pass near the Sun. Asteroids drift between Mars and Jupiter in the asteroid belt, colliding, breaking apart, or occasionally being nudged into new trajectories. All these movements occur simultaneously, layered on top of one another, forming a symphony of motion that is both chaotic and beautifully ordered. From the perspective of time, this constant motion has quietly shaped the history of our world. As the solar system orbits the galaxy, it periodically passes through the denser spiral arms where stars are born and supernova explode. Some scientists speculate that these encounters may influence the Earth's climate and even the rhythm of mass extinctions, as cosmic rays and dust clouds affect the amount of sunlight reaching our planet. Though such ideas remain the subject of study and debate, they remind us that our journey through the Milky Way is not just an abstract motion. It is a living, evolving experience that connects the fate of our world to the larger cycles of the galaxy. The Sun's voyage is guided not only by the visible stars, but also by the unseen mass of dark matter that envelopes the Milky Way like a hidden halo. This mysterious substance, which neither emits nor absorbs light, exerts gravity that shapes the motion of stars throughout the galaxy. Without it, the outer stars, including our Sun, would drift away into intergalactic space. Instead, dark matter's invisible hand holds everything together, ensuring that the galaxy's spiral structure endures. As the Sun moves, it carries us through regions influenced by this unseen force, a reminder that much of the universe is still beyond our understanding. Despite all this motion, we rarely feel it. On Earth, gravity binds us to the surface, and the atmosphere moves with us, so there is no wind of galactic travel against our faces. Yet in every moment, we are moving faster than we can truly imagine. The Earth spins at about 1,000 miles per hour at the equator, orbits the Sun at 67,000 miles per hour, and together with the Sun, races around the galactic center at 500,000 miles per hour. Add to that the motion of the Milky Way itself through the universe, about 1.3 million miles per hour relative to the cosmic background, and you begin to realize that even as you sit perfectly still, you are hurtling through space on a journey without pause or boundary. This constant motion gives the cosmos its living character. Nothing in the universe stands still. Everything is part of a grand, ceaseless flow of energy and gravity. Stars are born, move through the galaxy, and die, seeding the next generation of stars and planets. Our sun is just one among billions taking part in this endless migration. Each orbit, each motion, each gravitational pull is part of the silent rhythm that keeps the Milky Way alive. And somewhere within that rhythm, we move too, unaware yet inseparable from the motion that carries us across the deep, star-filled gulf of the galaxy when we gaze at the night sky. The Milky Way stretches across the heavens as a hazy river of light, a luminous band that seems within reach, yet represents something almost incomprehensibly vast. What we see is just the faint glow of billions of distant stars, packed so tightly that their individual light merges into a misty stream. But that stream is only a glimpse of the colossal structure we inhabit, a spiral galaxy spanning more than 100,000 light-years from edge to edge, containing hundreds of billions of stars, and enveloped in a massive halo, invisible dark matter that extends even farther into the cosmic void. To understand the true scale of the Milky Way is to confront the sheer magnitude of space itself, and to recognize how small and precious our place within it really is. The Milky Way is shaped like a giant, flattened disk with graceful spiral arms that coil outward from a dense central bulge. These arms are not solid structures, but vast regions of dust, gas, and young stars, where gravity and motion work together in a kind of cosmic dance. Each arm is thousands of light-years wide and millions of light-years long, slowly rotating around the galactic center. If you could see our galaxy from far above, it would resemble a swirling pinwheel of glowing light, its arms glimmering against the dark backdrop of interstellar space. The spiral pattern itself is not static, but maintained by waves of gravitational density, areas where matter compresses, triggering the birth of new stars, which illuminate the surrounding dust like cosmic beacons, before eventually burning out and fading back into darkness. At the heart of the Milky Way lies the galactic bulge, a densely packed region of old stars surrounding the supermassive black hole known as Sagittarius A. This bulge stretches roughly 10,000 light-years across and is rich with ancient suns that have burned for billions of years. The black hole at the center, containing about 4 million times the mass of our Sun, exerts a gravitational dominance that holds the core together. Surrounding the central region is the galactic disk, where our solar system resides, a vast, thin plane that makes up most of the Milky Way's visible structure. The disk itself is about 1,000 light-years thick, but it stretches outward for tens of thousands of light-years in every direction. Within this flat expanse, stars orbit the galactic center at incredible speeds, completing their rotation every few hundred million years, each one tracing a path defined by the pull of billions of others. If we were to zoom out, beyond the disk and the spiral arms, we'd encounter the galactic halo, a nearly spherical region that extends more than 300,000 light-years from the center. This halo is home to ancient globular clusters, each containing hundreds of thousands of tightly packed stars, some of which formed shortly after the universe itself began. The halo also contains enormous amounts of dark matter, an invisible substance that does not emit light but reveals its presence through its gravitational effects. Without dark matter, the Milky Way's spiral structure could not hold together. The outer stars would simply fly off into space. Instead, this unseen halo forms the galaxy's skeleton, keeping everything bound in a cosmic equilibrium that has lasted for billions of years. Our solar system is located about 27,000 light-years from the galactic center, nestled in a quiet suburb between two major spiral arms, the Sagittarius arm and the Perseus arm, within a smaller segment called the Orion Spur. This is our cosmic neighborhood, a relatively calm region compared to the crowded and energetic core. Here, stars are spaced so far apart that even the closest one, Proxima Centauri, is more than 4 light-years away. To put that into perspective, if the Milky Way were scaled down to the size of the continental United States, our solar system would be smaller than a single grain of sand drifting somewhere in Kansas. The vastness surrounding us is almost beyond comprehension. Light itself, the fastest thing in the universe, would take over 100,000 years just to travel from one side of the galaxy to the other. And yet, even at that enormous size, the Milky Way is far from the largest galaxy in the universe. It is a mid-sized spiral galaxy among an estimated 2 trillion galaxies scattered across the cosmos. Some, like the Andromeda Galaxy, are even larger, spanning over 200,000 light-years and containing perhaps 1 trillion stars. Others, like dwarf galaxies orbiting the Milky Way, are much smaller, holding just a few billion stars or less. The Milky Way itself belongs to a small cluster known as the local group, which includes about 50 galaxies, all gravitationally bound together. Beyond that, our local group is part of a massive cosmic web, an interconnected network of galaxy clusters and filaments stretching across the universe on scales that defy imagination. To truly appreciate the scale of the Milky Way, it helps to think in terms of time as well as distance. The Sun, for example, takes about 230 million years to orbit the galactic center once. That means, since the Sun formed 4.6 billion years ago, it has completed only about 20 orbits around the galaxy. During that time, entire continents have shifted on Earth. Species have evolved and gone extinct, and civilizations have risen and fallen, all while our solar system has slowly drifted through different parts of the Milky Way. Every night sky we have ever seen, every constellation and star we've charted, has been viewed from a constantly changing point along that endless path. Within the galaxy, stars are not distributed evenly. The central regions are densely packed, with stars separated by just a fraction of a light year. But out here, in the quieter outskirts, the nearest stars are light years apart, and vast voids of empty space stretch between them. These gaps are filled with thin clouds of gas and dust, remnants of long-dead stars, and the raw material for new ones yet to form. The galaxy is constantly recycling itself. Stars are born from interstellar gas, live their luminous lives, and eventually die, returning their material to the galactic medium. Over billions of years, this cycle of birth and death has built the Milky Way's majestic spiral arms, each one a living record of cosmic evolution. Even the light we see from the Milky Way carries a story written across time. The photons reaching our eyes tonight may have left their source thousands or even tens of thousands of years ago, crossing the void of space before entering our atmosphere. Every glance toward the galactic center is a look into the past, toward stars that may no longer exist, but whose light still travels onward. In that way, the galaxy is not just vast in size, but also in history, a living chronicle of billions of years, woven together by gravity and light. The immense scale of the Milky Way is something the human mind can barely contain. Our measurements of light years, parsecs, and galactic rotations are attempts to quantify something fundamentally beyond our direct experience. Yet within this enormity lies the fragile oasis of Earth, a small world orbiting an average star, itself one among hundreds of billions. And though we are so small within this immensity, our awareness allows us to measure, to wonder, and to dream about our place in it all. Beyond the shimmering arms of the Milky Way lies a vast, intergalactic wilderness, a space so immense and silent that even light, the universe's fastest traveler, takes millions of years to cross it. Though we are bound to our home galaxy, we are not alone in the universe. The Milky Way drifts within a grander community of galaxies known as the local group, an assembly of more than 50 galaxies, large and small, connected not by proximity in the familiar sense, but by the invisible web of gravity that binds them together across unimaginable distances. To understand our cosmic neighborhood is to recognize that the Milky Way itself is just one island in an ocean of galaxies, each carrying its own collection of stars, planets, and cosmic stories unfolding across billions of years. At the heart of this neighborhood lies a delicate gravitational balance between the Milky Way and its nearest major companion, the Andromeda Galaxy. also known as M31. Andromeda is a spiral galaxy much like our own, but even larger, spanning over 200,000 light-years, and containing perhaps twice as many stars. It lies about 2.5 million light-years away, which means that the light we see from it tonight began its journey long before humans existed on Earth. If we could view Andromeda with the naked eye in perfect darkness, we would see it as a faint smudge in the night sky, a reminder of how vast the universe is and how small our own galactic home becomes when viewed in context. Despite the great distance between us, the Milky Way and Andromeda are moving toward each other at an astonishing speed, roughly 250,000 miles per hour, drawn together by their mutual gravitational attraction. In about 4 to 5 billion years, these two galaxies will collide and merge, forming a new, larger galaxy that astronomers call Milky Way. The stars themselves are so far apart that very few will actually collide, but their orbits will be reshaped, their paths redefined, and their collective light will merge into a new galactic form. Surrounding the Milky Way and Andromeda are dozens of dwarf galaxies, smaller companions that orbit like satellites around these giant spirals. Some of these, such as the Large and Small Magellanic Clouds, are visible from the southern hemisphere as hazy patches in the night sky. These dwarf galaxies contain only a few billion stars, a small number compared to the Milky Way's hundreds of billions, yet they play an important role in the galactic ecosystem. Many of them are being slowly torn apart by the Milky Way's gravity, their stars and gas stripped away to form streams that wrap around our galaxy like faint ribbons of light. Others may one day merge entirely, adding their material to the Milky Way's growing mass. In this way, galaxies grow and evolve through a process of accretion and merger, consuming smaller neighbors in a slow, cosmic feast that has been ongoing for billions of years. The local group itself is a vast space, roughly 10 million light-years across. At its center is a gravitational tug-of-war between the Milky Way and Andromeda, with both surrounded by swarms of dwarf companions. Other notable members include the Triangulum Galaxy M33, another spiral system that may be gravitationally bound to Andromeda, as well as numerous faint dwarf spheroidal galaxies barely detectable with modern telescopes. Together, these galaxies form a small family isolated within a much greater structure. Beyond the local group lies the local sheet, a thin, flattened region of galaxies that includes several neighboring groups. This sheet, in turn, is part of a larger cluster known as the Virgo supercluster, which stretches for more than 110 million light-years and contains thousands of galaxies arranged in vast filaments and voids. When astronomers map the distribution of galaxies in space, they find that they are not scattered randomly, but instead form an intricate cosmic web, an immense lattice of filaments where galaxies cluster together along invisible threads of dark matter. Between these filaments lie vast, empty regions called cosmic voids, where almost no galaxies exist. The Milky Way, Andromeda, and their companions lie on one of these filaments, a glowing strand in the immense cosmic tapestry that connects galaxy clusters across the observable universe. Every galaxy, every star, every planet we know of occupies a place on this web, shaped by the gravitational pull of dark matter, the unseen architecture that sculpts the universe on the largest scales. Within this grand framework, our local group is moving through space as part of an even larger motion, the drift toward the Virgo cluster, a massive collection of over 1,000 galaxies located about 65 million light-years away. The Virgo cluster itself is only one component of an even more colossal structure called the Laniakea supercluster, which spans over 500 million light-years and encompasses approximately 100,000 galaxies. In Hawaiian, Laniakea means immense heaven, an apt name for this breathtakingly large cosmic domain. It represents the region of space where gravity pulls galaxies toward a common center, a point astronomers have dubbed the Great Attractor. Even our Milky Way, tiny as it seems against this vast expanse, is being drawn toward that gravitational center, carried along by the silent, continuous flow of cosmic motion that defines the universe. Every galaxy within this web, from the tiniest dwarfs to the largest ellipticals, is a collection of billions of suns, each with its own planets, moons, and possibly even life. And yet, across these staggering distances, no signal or light from other civilizations has yet reached us. The immense separations between galaxies mean that communication, even at the speed of light, would take millions of years. If an intelligent species existed in a galaxy 10 million light-years away and sent a message toward Earth, it would not arrive until long after both civilizations had likely vanished. This vast separation gives a sense of cosmic solitude, a humbling realization that, though we share the universe with countless other galaxies, the spaces between them are so immense that each may remain forever isolated. A silent island in the intergalactic sea. To grasp the enormity of our cosmic neighborhood, consider that every galaxy you can see with the naked eye from Earth, including Andromeda and the Magellanic Clouds, lies within the local group. Every other galaxy, visible only through telescopes, is millions or even billions of light-years farther away. When the Hubble Space Telescope pointed its lens at what seemed like an empty patch of sky in the Hubble Deep Field image, it revealed not darkness, but thousands of galaxies, each a universe unto itself. That single image represented just a fraction of the sky, yet within it were more galaxies than there are visible stars from Earth. It reminded humanity that the Milky Way is but one spark among countless others in an infinite ocean of light, our cosmic neighborhood. Then, both intimate and infinite, a network of galaxies held together by gravity and expanded by time, moving through space like driftwood on a boundless cosmic tide. The Milky Way, with its hundreds of billions of stars, is merely a small participant in a grander pattern that stretches beyond imagination. Even as we map it, measure it, and study it, we can never truly grasp its full extent, for every discovery only reveals a deeper layer of the universe's intricate design. The local group, the Virgo cluster, the Laniakea supercluster, all of these are steps in an ever-expanding hierarchy of cosmic structures, each reminding us that our place in the universe is both vanishingly small and profoundly connected to everything that exists when we step back to view the universe as a whole. Beyond the familiar blue of our skies, and even beyond the glowing arms of the Milky Way, we are faced with a truth that is both humbling and awe-inspiring. We are small, not just small in size, but in scale, in time, in the grand design of existence itself. Yet within that smallness lies a profound beauty, a spark of awareness that allows us to comprehend the vastness we are a part of. The cosmic perspective begins with this realization that our existence is a fleeting flicker in an infinite expanse. And yet, that flicker is capable of perceiving the cosmos, of asking where we come from, and of understanding how everything fits together in this boundless universe. To see ourselves from this perspective is to recognize that the Earth, our home, is nothing more than a tiny sphere of rock and water orbiting an average star in a spiral arm of the Milky Way. If one could step back far enough to view our galaxy from a great distance, the Sun and its planets would vanish into invisibility, lost in the glittering blur of 400 billion other stars. And yet, within that blur, arose self-aware, curious, and capable of wonder. This is the miracle of scale, that within a cosmos of incomprehensible size, consciousness exists in one tiny corner, capable of observing and reflecting upon the entire universe. From a purely physical standpoint, humans are made of the same material as the stars themselves. The carbon in our cells, the calcium in our bones, the iron in our blood, all of it was forged in the hearts of ancient stars that lived and died long before the Sun was born. When those stars exploded as supernova, they scattered their elements across the galaxy, seeding future generations of stars and planets with the building blocks of life. In this way, every human being carries the legacy of the cosmos within them. We are, as the late Carl Sagan so beautifully said, star stuff contemplating the stars. The cosmic perspective reminds us that we are not separate from the universe. We are its expression, its awareness, its way of knowing itself. When we look up at the night sky, We are not simply gazing at distant points of light. We are looking across time. The light from the nearest star, Proxima Centauri, takes over 4 years to reach us. The light from the Andromeda Galaxy has been traveling for 2.5 million years, crossing the void long before humans walked the Earth. Even the faint glow of the cosmic microwave background, the afterglow of the Big Bang, carries the story of the universe's earliest moments, imprinted more than 13 billion years ago. Each photon that reaches our eyes is a message from the past, a fragment of history that allows us to piece together the narrative of creation itself. Through the science of astronomy, we have learned not only where we are, but when we are living in a universe that has been expanding, evolving, and creating for nearly 14 billion years. To truly appreciate the cosmic perspective, we must consider scale in terms of both space and time. The distances between celestial objects are so immense that we measure them, not in miles or kilometers, but in light years. The distance light travels in 1 year, nearly 6 trillion miles. The time spans of cosmic events are equally immense. Stars live for billions of years, galaxies evolve over eons, and the universe itself changes only slowly, on a timescale beyond human comprehension. Against this vast backdrop, human history, every empire, every civilization, every story occupies only the briefest instant. If the history of the universe were compressed into a single year, the Milky Way would form in May, the Sun and Earth in early September, and all of recorded human history would take place in the final seconds before midnight on December 31 Street. And yet, despite our smallness in this cosmic calendar, humanity has achieved something extraordinary. We have reached beyond our world, sending probes to other planets, walking on the moon, and launching telescopes that gaze deeper into space than any eye has ever seen. We have deciphered the language of light, measured the age of the universe, and mapped its structure across billions of light years. This ability to comprehend the cosmos from within it is what makes our existence so remarkable. The universe gave rise to beings capable of understanding it, and in doing so, became self-aware. The cosmic perspective also reshapes how we see ourselves as a species. When viewed from afar, national borders, political divisions, and personal conflicts vanish into insignificance. From the vantage point of space, Earth appears as a single, fragile world, a glowing blue marble floating in a sea of darkness. Astronauts who have seen it with their own eyes often describe a profound sense of unity and reverence, an emotional transformation known as the overview effect. As we draw our journey to a close from the heart of our solar system to the edges of the Milky Way and beyond, we find ourselves standing at the intersection of wonder and humility. Through every scale we have explored, from the orbit of our tiny planet to the grand structure of the cosmos, one truth emerges with breathtaking clarity: we are small, yet we are connected to everything. The dust that built the stars also built us. The gravity that shapes galaxies holds our feet to the Earth. The light that has traveled billions of years across space ends its journey in our eyes, where it becomes thought, reflection, and a dot in the quiet immensity of space. Our entire world is a faint spark, a single pixel suspended in an ocean of stars. Yet within that pixel lies everything we know, every poem written, every child born, every act of love and discovery that has ever taken place. When viewed from the cosmic scale, our divisions fade, our pride dissolves, and what remains is the shared truth of our existence, that we are travelers together, adrift on a small world orbiting an ordinary star. Carried within the vast spiral of the Milky Way, the cosmic perspective does not diminish the human story, it magnifies it. For in a universe that stretches beyond imagination, consciousness has arisen to ask questions, to explore, and to dream. Against all odds, a fragile species of stardust has learned to look back at the galaxy that birthed it and whisper. We understand. That whisper echoes through time, a declaration of awareness amid the silence of infinity. Our place in the universe is not defined by size, but by significance. The significance of knowing that we are part of something greater, that our lives are threads woven into the fabric of cosmic time. We may never cross the distances between stars or galaxies, but through the power of curiosity and imagination, we already have. We have reached out with our minds and touched the edge of eternity. So, as the Milky Way turns silently above us, and as the Earth continues its endless voyage through the galaxy, let this truth settle gently in your thoughts. We are the universe made conscious, the cosmos looking inward at itself. Every heartbeat, every breath, every flicker of wonder is the universe remembering its own story, written in starlight, carried through time, and spoken softly in the language of human awe.